All right, so basically what that means is this count how many signs change. Basically, if you are looking, if it's in standard form and you're looking at the first term and it's a positive, then you just go to the next one. If it's positive, that doesn't count. But if it turns into a negative, that's 1. And then you count it again, and then it's 2, depending on how many times the signs change. Then you go down by a positive even integer. All right? It definitely is, yes. All right, which I'll push back to Thursday, just as FYI, so it's not due tonight. I forgot where I was going with this. Positive. Oh, so basically, so if my answer was 4, then you would go down positive integer. So I'll go down by 2, so that's 2. Then I go down by 2, it's 0. But watch out as well. If I get 5, positive integers going down would be a what?
4.
Right? So a positive even would be 2 more, so that would be 3. Because you're going down positive even integers. So basically, you're going down by 2. Right? That's a 2, by the way. All right, I think it's about to crash. Yep, there it goes. Okay, that's as best as I got. So let's just rewrite it. For positive real zeros. So positive real zeros, signs change in f of x. I need my brain to brain. All right, so signs change in f of x, and then we're going to go down by 2. So again, if it's a 4, that goes down to then 0. If it's a 5, it goes down to 3, then 1. All right, but that just means that there could be 4 possible zeros, or 2 positive zeros, or 0 positive zeros, or 5 positive zeros, 3 positive zeros, 1 positive zero. That's just how many positive zeros we could have. Same concept with the negatives. This time I want to plug in f of negative x. So after I put in negative x, I'm going to count the sign changes again. So signs, come on, G, change in f of negative x. All right. And it does the same thing. It decreases by positive even integers. So I'm going to go down by 2. So same concept. If it's a 4 sign changes, then it's 2. And that would represent your negative real zeros. So that's basically the gist of all that. You can write it word for word, or you can write what's in blue and highlight it and underline it. The key stuff there. Well, let's apply it to a problem. Do we have it all written down? Oh, pausing. Gets rid of that awkward silence, huh? Well, we're on objective 3. Oh, wait, what point? Like on the little, in the purple box? We're still at 3.4. So we are behind. Including, and 3.6. Well, 3.6 is always already on Thursday. Yeah. So that's where we're at right now. It's a good question. All right, do we got this written down?
Yes.
You positive or negative? Get it? Because it has positive and negative on the screen? Okay, that's good. All right. All right, so all we're going to do on these type of problems is we're going to determine the number of possible positive and negative real zeros. We're not going to go find the zeros. We just want to know how many possible positive and negative zeros. So start off by just counting the sign changes. So I'm at negative, then I go to a positive. So that counts as 1.
Whoa, wait a second, I thought it was. Whoa, we are good.
So far, I just wrote a 1. Good. So there's a second sign change. But then that's still a negative. Where is the rest of my... It is. It's a positive. Yeah. Gotta love this. Good. So then that would be another one. Then another one. Then another one. Right? So how many sign changes are there? Okay. So that means we could have as much as... So there could be 5 positive zeros, or 3 positive zeros, or 1 positive zero. Because I probably didn't give you a chance to write it down. Math just excites me, guys. You gotta just hit that pause sign. Not every time. This situation, it could be a whole bunch of plus signs, and then there's no sign changes. Not necessary either. That would be if I don't have any missing terms. If I have missing terms and they're all even and odd, this goes back to our even and odd functions that we went over. It all depends on what happens there. Are we ready? Okay, so yes, so if you plug in the negative, this becomes negative 4 to the negative x, or sorry, negative 4 times negative x to the 9th. Nope, that's negative f of x, which is not the same thing as f of negative x. Remember, with this concept, I'm replacing x with a negative. I see now where you're at. If I don't write big, it doesn't read it small. Not like the other screen. If I could just record the screen of the TV, I think my life would be easier, because that doesn't glitch as much. Then I'm in the video. That just becomes awkward. All right, ready? Okay. All right, so now we're just going to simplify this. A negative x raised to an odd exponent means the result's going to be negative. So that means the sign will change. So that becomes 4x to the 9th. Right? Because that result is negative. It was already negative, so therefore it becomes a positive. So think of it like this. Odd exponents, the signs change. Even exponents, the sign stays the same. So this becomes a positive 6x to the 8th. This becomes positive 5x to the 5th since it was a odd. What about the next one? Would it stay the same? Yep, good. So negative 2x to the 4th. What about this one? Stay the same. So 3x squared. What about this guy? Changes. Very good. And what about the 8? Just stays the same. All right. So how many sign changes does it have? I see 1. I think that's it. So then the negative zeros we have, huh? Where? Yeah, there you go. Good y'all. Good. Positive, negative, positive. That's 2. Good. So negative. There you go. So 2 or 0. So that tells you how many zeros you could have, positive or negative, when you're guessing a whole bunch of different numbers to limit it down. All right, we got it?
Wait, I have one thing. So, you know how we get to a quadratic? So, when we're doing it actually, and we were trying to find, less than, but you get small numbers like less, what do we mean? And so we find 1, 0. We find 1, 0. And then we plug it into the quadratic if it's small enough.
If it's small enough. If, like, for instance, when we had a quartic, it only went down to a cubic, so we had to go find another 0 to get it down to a quadratic. And then at that point, we can factor or use the quadratic
So
formula.
if it's like a small problem and it's like actually 4, it's going to be like 3 or
There's going to be 2 zeros at least. Well, not always. I mean, yeah.
Because as soon as you can, you plug it into the quadratic, and you're only going to get 1 or 2, right?
Or none. Right? Because if we plug it in, we get a negative square root. Then there's no real zeros in that direction either.
Okay.
So when it gets down to a quadratic, you could have 1, 2, or none. 5 minutes. All right. Objective 4. Talking about upper and lower bonds. Now, I'm going to show you this because I know it's on your homework. But if it does not give you an idea to determine if it's upper or lower bond, I've never found this technique to be any easier to shorten your range of zeros. Because you still have to guess an upper bound and a lower bound to see if your zeros are going to fall in there. So you're still guessing the numbers for your zeros. But if it gives you some, then the concept is pretty easy. There is an E in zeros.
Like another one, like after
Oh, yeah.
grammar,
Grammar, spelling.
spelling. What?
All right, real quick. To reflect on this, for it to be an upper bond, when we apply the synthetic division, is there? Sure. All right. All right. To find an upper bound, when you do apply the synthetic division, you want all of the quotient coefficients. If it would just write the words I want it to write, that'd be great. Yep. Quotient. Oh, that's an O. The I's here. Okay. Quotient. All right. Coefficients. Hey, I think it's decent. I think there's 2 I's there. I don't ever know. All right. Quotient coefficients have to be positive. to be an upper bound. Quotient coefficients are your answers. So it's in that third row, all those answers you get underneath the bar, that's your quotient coefficients. We'll pick it up from there tomorrow. The signs need to alternate, including the remainder.